Okay, here we're going to be talking about global winds and global wind patterns. Be sure to pause the video so that you have enough time to write in the items as we progress. Now, a few things to keep in mind about the names of these winds is that wind is named by where it's coming from, not where it's going to. So you'll notice this first one, the polar easterlies. These are wind belts that come from the polar regions, hence the name, and are usually from the east. And hey, you guys remember how ridiculously cold it was this winter? Well, that was because of polar vortex. That's what we're talking about here. Okay, then westerlies, as the name suggests, typically come from the west. These are mid-latitude wind belts, so that means it's our region. So here between 30 and 60 degrees north, but then also in the southern hemisphere between 30 and 60 degrees south. And then we have the trade winds. These are the wind belts on either side of the equator. So down here and up here, between 0 and 30 north and 0 and 30 south. And these wind belts typically come from the east. Now from here, we're going to be talking about labeling this diagram in front of you. Obviously, if you haven't figured it out, this diagram is representing the Earth. And we're going to need to remember a few patterns that we've discussed. First, say this out loud along with me. As the air rises, and as it cools, it will to form. Now, I'm going to assume it was a little bit awkward and that you guys didn't say it at first, so let's try this again. Everyone, say this out loud. As the air rises, and as it cools, it will to form. Okay, much better, I hope. So, we'll be looking at the clouds forming in certain areas and then other areas where the air is sinking and so therefore not forming clouds. And this will go right along with what we just talked about on the first page where we were talking about high pressure and low pressure, and the low pressure is associated with the rising air. Now, we'll start along the equator. And at the equator, which gets plenty of sun, we have, of course, a regional low pressure system. It's typically at lower pressures because that sun, as you know, heats up the air, the molecules speed up and spread out, which gives us an area of low pressure. We call this the equatorial low. Sorry. And what we'll do along the side of each of these is draw in what the air is doing. You'll need red and blue colors for relatively warm and relatively cool things. So we're going to start along the surface, and as we've discussed, at a low pressure area, the air on the surface is converging, so coming together and then rising. And as it rises, it cools, so transition to blue. And when we get up top, it will then diverge outward. But as it cools, it will condense to form clouds, so we also have a weather belt here with this equatorial low. So we'll have some cloud development typically in this area. Now, on either side of the equator, we have then the opposite going on at the 30 north and 30 south latitude. Those are called subtropical highs. It's subtropical because it's just outside of where the tropic zones are, so hence subtropical high. So label that in both 30 north and 30 south. Okay, and we'll come back to labeling what the arrows are doing on the side. Now, the pattern flip-flops every time. So whereas that was a subtropical high, then below that is the subpolar low. subpolar because it's just outside of the polar zone. And low because the one next to it was a high. And at the polar regions, we have a high. Again, because high, then low, then low, then high. So down here, polar high. And label these things also on the top side. The subtropical low, I'm sorry, subpolar high, low. Subpolar low, and then the polar high. Okay, then we're going to continue the patterns of the arrows from here. So with the subtropical high for the 30 north latitude region, we have cool air coming in from above, and that's where it converges, then heads down. Bring that in from both sides. Since the air is sinking, it's, well, not rising, not cooling, not condensing, not forming clouds, so we're not going to draw any clouds. But as that air is sinking, it can get a little bit relatively warmer, and it will then diverge at the surface. And that will be true with subtropical high on both sides. Cool air coming in and sinking, warming up and diverging on the surface. Then we move to the subpolar low, and here at a low, what is the air doing? Rising. And as the air rises, and as it cools, it will to form. All right, so we've got this warm air coming in and rising and cooling, and then diverging. Now, from the polar region, I'm still going to stick with blue because this air is still just that frigid. Yes, it will get even colder as it rises, but it starts off pretty darn cold. And don't forget your clouds here because this is a low pressure area. And we've got to draw in those same arrows up top. Warm air coming in, rising at 60 north, cooling, then diverging. Don't forget your clouds. We have cool air coming in on the surface, rising and becoming even colder, going outwards and diverging. And then the final set of arrows will be for the polar high, which being high pressure area, the air will sink up at the poles. It's definitely cold air. It only gets colder as it sinks. Well, I'm sorry, no, it does not get colder as it sinks, but it sinks, it stays cold, and then travels along the surface. And down here at the South Pole. Now, keep in mind that this is a two-dimensional representation of something that's really happening in 3 dimensions. So, if you hadn't noticed already, here I've got the 3D, attempt at 3D diagram of this, and you can see how this is not only happening on the side of the Earth, but it's actually all around. And here's those clouds that form at those low pressure areas. So there's the polar low and the equatorial low, and there's another polar low down there. But since it's happening not only on just the side of Earth, which being a sphere has no actual side, we also need to draw in the wind directions for these wind belts that we talked about, those polar easterlies and the westerlies and the trade winds. Now, the polar easterlies, also called polar vortex, is very cold, so we're going to draw this with a blue arrow. And they're coming from the east, and they're headed towards the low pressure, because as we've discussed, wind moves towards low pressure. It's trying to equalize, going from the high pressure to the low. So then we get these diagonal arrows in such a fashion. This is a polar easterly. And here in the mid-latitude regions, we have what are called westerlies. These are somewhat warm. Again, they're going to diverge from the high and head towards the low. And they're westerly, so they're coming from the west. These are drawn in that direction. Oh, and just to remind you, if you have trouble with this sort of thing, here's your compass rose. Never eat soggy waffles. So you can see then how this is from the west, headed towards the east. Well, it's actually from the northwest, obviously, but then headed down towards that subpolar low, away from the subtropical high. Then in the tropical regions, we have what are called the trade winds. And that's on both sides of the equator. But just to distinguish the two, we also call them by their directions. So in the, let's draw the arrows first. In the southern hemisphere, we're going away from the high towards the low, and our arrows are like that. In the northern hemisphere, our arrows look like that. Take a second to consider, where are these arrows coming from? Northeast, northwest, southeast, or southwest? In the southern hemisphere, it is coming from the southeast. So those are the southeast trade winds. The northern hemisphere, they're coming from the northeast. So those are called the northeast trade winds. And again, up here in the mid-latitude regions, we have yet again the westerlies. And they're going away from the high and from the west, so we get arrows diagonally that direction. And last, we got to put in the polar easterlies. Oops. Technical difficulties here. Sorry about all these excess bizarre marks on the map. Ugh. All right, I'm sorry, kids. I cannot undo that. Luckily, you already wrote it in. Where were we? Polar easterlies. These are cold, so we got blue. They're headed towards the low and out of the east, so we get diagonal arrows like that. Okay, the last thing to consider on here is that right here, 30 south and 30 north, these areas are very well known for deserts. The major deserts on this planet that you could think of fall very close to and or directly on either 30 north or 30 south latitude. The Atacama deserts, the driest desert, the Sahara desert, the largest desert, the Gobi desert, the deserts out in the Nevada area, the outback of Australia. These things fall on either 30 north or 30 south latitude. Now think for a minute about why are these deserts? Now the obvious answer is because they're very dry. Now what I want you to further consider is why are these areas typically so very dry? Now this will be like a guaranteed short answer question on a test or a quiz or both. So if you're not able to figure this out, make sure and ask me next time you actually see me in person, because you do need to understand why it's so typically dry here and here, and as to why then we get the deserts there.